Hello there. In this video we're going to be looking at scale factors as well as scale diagrams. So these two are going to be related. It says when enlarging or reducing a diagram of an object, a scale factor must be applied to ensure proportionality. So imagine if you were like increasing a statue size. You couldn't just make it taller, you'd also have to make it wider. So it has to be enlarged or reduced in the same amount in all of the directions or dimensions that you have. So the first thing we're going to do is a scale factor investigation. So it says, are the following proportional, and then how do you know? So to figure out whether they are proportional just means that all of the sides are going to be multiplied by the same amount. So we can see with this first one, it went from this bottom side to this bottom side, and to get there, looks like it times by 3. And then this right side, to get to this other right side, it also times by 3. So with that one, it multiplied both of the dimensions by the same amount. Looking at the triangle one here, I can see that the base, it went from a 6 to a 3. So to get from the 6 to the 3, they multiplied by a half. And then also for the 8 to get to the 4, they also multiplied by a half. So in both cases, we could say yes, they are proportional. And then for being asked, how do you know? We'd kind of alluded to this before, but anytime you multiply all of the dimensions by the same amount, then that tells you it's going to be proportional. So all sides are multiplied by the same amount, or in this case, I just said the same number. Now, the one thing I'm going to make a note of here is it has to be multiplied. You couldn't say, well, to get from 8 to 12, you added 8. And then tried to say add 8 with this one. It's never with adding or subtracting, it's just with multiplying. So the value that we actually got here, this 3 and this half, that's going to lead into our next thing. So that number that we found is called the scale factor. So it's represented by a variable, and we use the letter k. So in this case, our k for this one is a half, and then our k for this other one here is a 3. So I'm just going to write that for these ones. This one, k was equal to a 3, and then with this other one, k was equal to a half. Or you could also write it as a decimal. You could say it's 0.5. So back now down to our scale factor. So we use the letter k, we had said. The next thing, it can be written as a fraction, a decimal, or a percent. So like up here, this is a decimal, this one's a fraction, and then we could write this one as a percent. It would be 50%. It's 50% of the size. And we're going to see another example like that later on. The third point says is a number created from the ratio of any two corresponding measurements of similar shapes or objects. So these two objects, we can see they're both triangles. They're the same kind of shape. They're similar shapes. And the sides also have to be corresponding. So corresponding means like if I looked at the bottom of this one, it has to be the matching or the corresponding side that goes with it. So it'd have to be the other bottom side. And then our last point, it says it has no units because they cancel. So in order to get units to cancel, therefore the units must be the same. So I could give you a quick example. If you had 5 centimeters over 2 centimeters, the centimeters would cancel and you just get 5 over 2, and then that would be your scale factor. Just like up here with these ones, there's no units, it's just a number, it's just a factor. And depending on what that number actually is, like here we had a half and here we had a 3, that's going to determine whether it makes it smaller or bigger. So this one we got bigger and we had a 3. This one our triangles got smaller and we got a half. So down below here are characteristics. If k is greater than 1, so if k is large, it's greater than 1, you're going to get an enlargement. If k is between 0 and 1, what you get is a reduction. So try to think of it like if you had k was equal to a half, if you tried to take half the size of something, that's going to make it smaller. Whereas if you had, say, k was equal to 2, if you took twice as much of something, you doubled it, it's going to get larger. So if you have trouble kind of remembering this, just think about it logically with some numbers. And then the last characteristic is if k is equal to 1. So imagine if you took something and you multiplied by 1. Let's do a quick example. We could take maybe 5 centimeters We'll times this by 1, and we get out 5 centimeters. So it didn't actually change. Anytime you multiply by 1, it's not going to change. So the dimensions for something that has a scale factor of 1, it's not going to change anything, so the dimensions just stay the same. Next, we have some formulas that we're going to be using for when we're calculating our scale factor. There's going to be 2 of them, and there they are right there. So the first one is K. Remember, K stood for scale factor. You just take the new measurement that's given and then divide by whatever the original measurement was. Or you could have maybe a diagram measurement or a model measurement, and you're also given an actual measurement. So that could be like a model airplane wingspan and then an actual airplane's wingspan. So next we're going to look at our first example. It says the diameter of an animal cell that is represented by this scale diagram is actually 0.25 millimeters. So the actual measurement is 0.25 millimeters. And then it says what scale factor was used to draw the scale diagram. And I can see on my scale diagram, the whole width of this is actually 3.5 centimeters. So I'm going to write the formula out first for our scale factor. We use the letter K, and it was the diagram being divided by the actual. So diagram divided by actual, and we were given both of those measurements. So what we're going to have, the diagram is 3.5 centimeters, so 3.5 centimeters, and then the actual length, it told me right here, it was actually 0.25 millimeters. So 0.25 millimeters. But remember, with our scale factor, it was just a factor. There's no units that should be with it. So we got to somehow get these units to cancel, and the only way we can get those units to cancel is if they're the same. So we need to get the units to be the same. So what I'm going to do is I'm going to convert the centimeters into millimeters. And some of you might already know how to convert it or what that might be, but I can just show you. This is a little trick. It's King Henry died, mother didn't care much. And it's just the prefixes for the metric system. So it's kilo, hecto, deca, the base unit meter, deci, centi, milli. So we want to go from a centimeter to a millimeter. So I'm going to hop 1 over to the right. So 1 over to the right. And then I'll do the exact same with my decimal. So this is going to hop 1 over to the right. So then what I'm going to get is 35. And then my units are now millimeters because I converted to millimeters. And then in the denominator, we still have the same thing. But now they're both millimeters. So my millimeters can cancel out. And then I can just take 35 and divide by 0.25. And you're going to get 140. And because this scale factor is greater than 1, that's also going to tell me that this is going to be an enlargement. It's going to make it bigger. You could have also guessed that by just looking at the cell, right? This is huge. Cells aren't that large. Next, we're going to do example 2 here. And for this one, it says determine the scale factor that will transform diagram P to diagram Q. So we're going from P over to get to Q. And then we're expressing our answer as a fraction, a decimal, and as a percent. So we're starting with P. P is the original, so I'm just going to write that on there. And then we're moving towards Q, and Q is going to be the new one. And I can see on here, this is 1, 2, 3, 4 units on the base, and this one is 1, 2, 3. And to find our scale factor, I'm just going to write our formula up top here. Our scale factor, it was the new image divided by the original, or the new shape divided by the original shape. So to get that, our scale factor is going to be, for the fraction one, the new one, it had a length of 3, so we got 3, and then the old one, or the original one, it had a length of 4 there on the bottom. So we just get 3 over 4. And again, because this scale factor is less than 1, that's going to tell us that this is actually going to be a reduction. Plus, you could have also just looked at your triangles. It's getting smaller. For part B, we're going to do it as a decimal, so you can just put 3 over 4 in your calculator, and we get 0.75. And then the last one as a percent, our scale factor, if it was 0.75 as a decimal, you can just take that times by 100, so that is 75%. Moving on to our next thing, this is going to be dealing with scale diagrams, and we're also going to be comparing with our scale factor. So a scale diagram, all it is a drawing where measurements are reduced or enlarged proportionally from the actual measurements. So you take something, you make it bigger, you make it smaller. A scale is the ratio of a diagram measurement to the corresponding actual measurement. So it's the diagram measurement to the actual measurement. Or another way to say this, it's the new one to the original one. And again, another word for a diagram, you could also be given the word model instead. Now the difference between a scale and a scale factor is that a scale can have different units. So I'm just going to write that on the side. And next we're actually going to see an example of that. So in this 1.5, we're going to make a point of it. It says scale factor versus scale. So if an actual length of 6, and that means feet, so if 6 feet is represented on a plan by 5, and that means inches, then we could have two things. We could either get a scale factor or we could get a scale. So our scale factor is the diagram divided by the actual, and for scale factor you have to have the units canceling, so they need to be the same. So if we had the 5 inches divided by the 6 feet, these are different units, so we got to convert these feet into inches. So to do that you could times by 12, so I'm just going to write that, times by 12, and the reason we're timesing by 12 is because there's 12 inches in 1 foot. And then in the next step here we have the same units, they are both in inches, so now the inches would cancel and you just have a number, so it's just a factor. Whereas if you look at the scale, this is diagram to actual, so we take the diagram or the plan and then it's to the actual, which that was 6 feet. And then we don't have to convert anything, that's just our answer. And if we wanted to convert it, we could, but we have to keep our units in here. So scale factor has no units, scale has units. Otherwise, they're actually quite similar. So looking at our first example next, it says a model car has a scale of 1 to 18. If the model car has a length of 24.78 centimeters, what is its actual length? So remember, our scale goes diagram to actual. So I'm just going to write that above the numbers. So this is diagram to actual. So for every 1 unit on the diagram, it's actually 18 in actual, so in real life. So what I'm going to do down here is I'm going to write diagram and actual again, and then I'm going to write the numbers that we just got below it. So we had diagram was with 1, and then actual, that was with 18. Now the length that they gave me, 24.78, that it said was on the model. So the model is not the actual thing, it's like the diagram or the smaller version. So I'm going to put 24.78 centimeters on the diagram side, and then I don't know what the actual length is. That's what I want to find out. So to find out what that question mark is, essentially what I do is I just turn these into fractions and then make a proportion out of it. So I'm going to take 1 over 18 and then set that equal to 24.78, and this was centimeters, and then divide that by, I don't know what it is, so I'm just going to fill it in with an x. So to solve for x, we can use our cross multiply and divide, so it's going to be 18 times that 24.78 centimeters, and then divide by the 1 across from the x, which is just a 1, so that won't change anything. So 18 times 24.78 is going to be 446.04, and our units are centimeters. That was the only thing that we had right there, centimeters. Now what you should always do when you get your final answer is check to see whether it makes sense. If the model car was almost 25 centimeters and it asked for the actual one should be quite a bit bigger. So really what you guys can do is, if you got it wrong, you could just look back and check and see and basically do the opposite of what you did. So if we multiplied by 18 and that didn't make sense, you could just do the opposite and we could divide by 18. But in this case, larger number makes sense. So we have one more example here next. It says example 2, to create a billboard of a car, a diagram was drawn using a scale of 1 to 45. And again, it goes diagram first and then the actual is second. So part A asks the length of the car on the scale diagram, the small one, is 12.39 centimeters. What is the length of the car on the billboard, so on the large one. So I'm going to write my first fraction. I'm going to have 1 over 45. And then my scale one, that one has to go with the small one, the diagram one. So that has to go in the top of the fraction, just like this one went in the top of the fraction. So it's going to be 12.39 centimeters divided by, don't know what this is, so I can just put an x. And then to solve for that missing spot, x is going to be equal to, cross multiply, so I got 45 times 12.39 centimeters, and then divide by the 1 across from the x, always at an angle like that, so divide by the 1, which won't change anything. So 45 times 12.39, that's going to give me 557.55, and then my units are centimeters. The next one, part B, I'm going to do this one a little bit differently. So here it says the height of the car on the billboard is 162.5 centimeters. So that's the large measurement. What is the height of the car on the diagram? So what is it on the small one? So I knew that my scale was 1 to 45. And when I went to get the large one in this part A, what I did was I multiplied by 45. So now if I already have the large one and I want to get to the small one, I'm going to divide by 45. So this is actually a lot quicker if you just kind of know whether you have to divide or multiply. So it's going to be 162.5 centimeters, and we're going to divide by 45, and then that is going to give us 3.61, and then our units are centimeters. So that was our very last example. Just at the bottom here, we got our textbook questions, and it's going to be on 2 different pages. So we got page 471 and also on page 489.